Yeah. Hey guys. So today what we're going to break down is diastasis recti and linea nigra and its relationship with pregnant women. So what's important to notice is that we're going to break down the intra-abdominal or the abdominal muscles that help support us when it comes to intra-abdominal pressure, as well as its contribution towards linea nigra. We're going to explain diastasis recti at some other time. But what's important to notice is that we have these horizontal muscles, such as the transverse abdominis. This is going to be the deepest muscle layer within our abdominals. We then have the internal abdominal obliques, we have the external abdominal obliques, and then we have two vertical abdominals. This is going to be our rectus abdominals. This is all going to be held together by the rectus sheath. And we know this through a process called aponeurosis. I might have said that wrong, but aponeurosis is basically a sheath that combines all these together. We have our thoracolumbar fascia, which is in our back, which connects basically from our lower back all the way up to like the midline, and it connects from our shoulder all the way to our hip, our contralateral hip. It's very vital when it comes to movement, especially in that gait walking assessment. Again, we're going to explain that some other time, but today we're going to look at a very important part of the body, which is the linea alba. The linea alba is in both men and female, but it becomes especially noticeable as we look at women when they become pregnant. So this linea alba is right in between this rectus abdominis, and it's all the way down to around the pubic bone, all the way up to the sternum. And so linea nigra especially comes noticeable, or the linea alba becomes linea nigra when we have something such as the production of melanin in women that increase dramatically. And we're going to explain that today. We're going to explain as to what increases melanin, why melanin is increased, and as a result, why it produces linea nigra. So within the placenta, right, the placenta is vital for providing oxygen as well as nutrients within the uterus to provide for that baby that is going throughout that pregnancy process soon to be delivered. What is important to notice is that within this uterus, we have what is an increase of melanin. And this happens within the stratum basal, which we'll explain in a little bit as to why it's important, which creates this linea alba, which is that linea alba becoming dark, becoming linea nigra. And so to start out with, we're basically going to explain the main components of the skin. We of course have our epidermis, so it's going to be epi on top. We have our dermis, hypodermis, and then cutaneous layer. For today, we're just going to break down the split main components of between the epidermis and then the dermis at the bottom. So at the top, we have what's called our stratum corneum. Our stratum corneum is going to be vital for having what's called keratinocytes. Keratinocytes have no nuclei. That's very important to notice. It has no nuclei, as well as it has a fatty mixture that's over it, as well as H2O. It's very vital for being on top of our skin when having sweat. We'll explain as to why that's important a little bit. We then have our stratum granulosum. The stratum granulosum is going to produce this fatty mixture. It's going to go up. So it's going to go all the way from the bottom and then up. It's going to have its effect. And all these leftover products, as a result, these metabolites and products are going to end up in the stratum corneum. But the stratum granulosum is going to produce H2O as well as that fatty mixture. That fatty mixture is going to keratinocyze. As a result, it's going to become hard and it's going to be on our body. We then have H2O that's produced. H2O is vital for when we're thinking about these American sweat glands, which we'll explain a little bit, but also making sure that nothing goes through our pores. We have the stratum spinosum. Now this is interesting. The stratum spinosum is the first part of the skin between the epidermis and dermis that has nucleic cells. Specifically, it has nucleic keratinocytes. And so what the nucleic keratinocytes are vital for is, if we look down here, we have, of course, our stratum corneum, then we have our stratum granulosum, then right here, these stratum keratinocytes that have a nuclei, what they do is they bond amongst each other. They bond amongst each other, and they basically strengthen the epidermis and the dermis together. They're absolutely vital. We then, of course, have our stratum basal, and then we'll have our dermis at the bottom. But then we're going to go to our last thing. So that's our stratum spinosum. Then we have our stratum basal. And so the stratum basal, what I like to take into account is the stratum basal creates melanocytes. And so these melanocytes are going to be, as you would assume, vital for the production of melanin. And so I put a warning sign right here because there's one tumor in particular that these melanocytes can produce that is extremely harmful if not taken care of immediately. Okay, again, we have the epidermis and then we have the dermis, and breaking those down into main key components. You have the stratum corneum, stratum granulosum, stratum spinosum, and then the stratum basal. Okay, so if you go right over here, you got three diseases that are very vital that, or at least common, that I like to take into account. I always like to add diseases to certain parts of my study so that I can kind of memorize more and more as I go. So right over here, we have squamous cell carcinoma. And squamous cell carcinoma, and anything that ends with an oma is going to be a tumor, okay? So basal cell carcinoma, malignant melanoma, it's a tumor that needs to be removed. Squamous cell carcinoma is a reddish plaque that can metastasize. Metastasize means to spread, but it is easy to remove. It's quite common, actually. It's not something that necessarily needs to be worried about if found early. We then have basal cell carcinoma. This is the most common skin tumor, and it's also the least dangerous because it is also easy to remove. However, one thing I like to memorize is that the stratum basal is not only important for creating melanocytes, but it also produces one of the most dangerous tumors out there for the skin, which is malignant melanoma. The reason it's super dangerous is because it does metastasize and metastasizes fast. So if you don't find it almost immediately, there's a high chance that it's metastasizes, it spreads to the point that you're dead, you know? And that sucks. I think most people won't be alive. So, and they derive from melanocytes.
What do you mean when you say easy to remove or?
Easy to remove. Depending on specific parts of the body, let's say, so I don't know the exact process of removing the squamous cell carcinoma, basal cell carcinoma. I'm assuming when they're removing this tumor, they're just removing a part of the body that contains that tumor within the skin. But some parts of the body are going to be a little bit more difficult to remove than others. So if you think about, like, for the brain, for example, extracting a tumor from the brain or even the liver is going to be a lot more difficult than something that is subcutaneous or something that's on the epidermis. So to answer your question, I do not know the exact way as to how they remove the tumor. I would assume that the reason why it's super difficult is because if we look down here, the stratum corneum, stratum granulosum, the stratum spinosum, the stratum basal, it's going to be one of the deeper layers of the skin, so it's going to be a little bit more harder and difficult to remove. Remember, the stratum basal is the root between the dermis and the epidermis. So the more that's in the root in there, the more difficult one it's going to be able to find, right? Two, so it might not end up immediately on the epidermis, like squamous cell carcinoma, but it might just be more difficult as a result to remove as well.
And what are melanocytes sites again?
Melanocytes, they're going to be the cells that are going to create melanin.
I see.
So sites, anything that into a site is going to be cells. And so one thing is also important to count before we go on is that we also have these different parts of our body. We have the hypochondric lumbar region as well as the inguinal region. We then have the epigastric, umbilicus, hypogastric. They're basically in the same area, but again, I like to make connections as I study. And so we know that when it comes to linea alba, that's going to be connected between around the pelvis. So it's going to be around the pelvis all the way up into that sternum. So it's going to be around the inguinal region all the way up to around the epigastric region. One last thing, as we go on, we have three different things that I'm going to take into account as we are looking into the skin. We have merocrine sweat glands, we have apocrine sweat glands, and then we have sebaceous glands. And so the sebaceous glands are going to be vital for its production of sebum. As I explained earlier, that stratum corneum is going to have dead keratinocytes, which have no nuclei, as well as basically metabolites. And so these sebaceous glands are what's going to produce sebum. There's actually kind of a correlation with puberty and having excessive sebum and creating comedos, which are whiteheads. There's a connection with excess androgens as well as androgens like testosterone and estrogens that can help causes increase of these sebaceous glands for producing sebum, and as a result, these sebum can get stuck within a hair follicle and cause comedo, whitehead. We then have these apocrine sweat glands and then merocrine sweat glands. And so, I assume they're sweat glands, but they're a little different in its job as well as its texture and look. These merocrine sweat glands are going to be contracted via muscle, and they're going to go up through the sweat pore all the way on top of the body. And so we have this 99% and this 1%. Do you know what that 99% is when it comes to sweat? What that consists of?
Uh, water,
Yeah, water. And what do you think the 1% is?
salt.
Salt. Yeah, it can be sodium chloride. It can be a mix of electrolytes, right? And so we have these American sweat glands, which are going to be vital for producing sweat that we commonly see. We then have African sweat glands. And those are going to be a little bit more interesting. Those are going to be left over from the anus, as well as the groin, as well as the axilla, the armpits, and around the nipples. And
Ew.
so African sweat glands come from either sexual arousal or they come from stress. So they come from sexual arousal or stress, and they have like a weird white, cloudy mixture and a little bit more thick. Again, this is more uncommon unless you're in a situation where it's really stressful or sexually stimulating. But generally, American sweat glands are what's going to be produced. And one important thing to notice as well, these sebaceous glands, as they release sebum, the whole cell is going to die, as well the apocrine sweat glands. The partial loss of the cell membrane is what kind of releases then that the leftover cloudy metabolites mixture. Then we have this American sweat gland, which it's actually more conserving. It's just going to release these vesicles. Remember, vesicles can carry on neurotransmitters such as acetylcholine, but they can also carry molecules such as the secretion of what results as sweat. Okay. Any questions here so far?
I don't think so. No.
Okay. So then we're going to go over here. So we basically explained as to one, where are melanocytes? Where are they staying? They're staying within the sternum basal. We know that they create melanin. We know here that the placenta is what causes melanin production. So we answered that question, and we know that happens in sternum basal. But the real question is, and I have two things here. We have intra-abdominal pressure, which goes down. We'll go that later on with diastasis recti. But we need to look at as to why this melanin production. We know that as it increases melanocytes, that dark pigmentation that protects us from the sun, is vital. But we need to understand as to why there's an increase in melanin. And so we're going to break down two main vital components when it comes to the increase in melanin production, which is progesterone and estrogen. We're going to break it down very briefly for today, and then some other video will go down a little bit further. But we need to take into account is that cholesterol is mainly synthesized in the body. I think it's around 15 to 20%. It might even be 30% that comes from the diet, but around 70 to 80% is going to be created via the liver. Okay, the liver is going to have bile salts, bile acids. This is going to be very vital for breaking down what we have is called when we break down these fats, break down these lipids, they have chylomicrons which go throughout the intestines. They're vital for breaking these down. But we'll go into that some other time. What's important to know for right now is that, remember, most of the cholesterol that's synthesized comes from the liver, and they also come some from diet. And these come from lipids, carbs, protein. But when we do this process, right, these lipids, carbs, protein, we basically take an acetyl-CoA group, and from then on, we're going to help synthesize cholesterol, which is going to go out into the bloodstream. Now, it's going to go into the bloodstream, and it's going to be utilized by three very vital components: the ovaries, the adrenal glands, and the testes. I'm going to explain a little bit as to why these three parts of the body are vital when it comes to producing estrogens and androgens. So, very, very, very briefly, before we get into that, estrogens, we have estrone, estradiol, which is the strongest, and then we have estriol. So estrone can be a precursor or metabolite to estradiol. So that means that estrone can become estradiol, or it can be a metabolite, so it can be an end product of estradiol. It has the enzymes that can utilize it from going back and forth. Now, estriol is a one-way end product. So if you have estriol, you can't convert it to estradiol. You can't convert it back to estradiol. And the reason is we just don't have the enzymes to convert it back and forth. We have cholesterol. We'll go into that in a bit, but it's important that we do have 3 points: estrone, estradiol, and estriol. And remember, estriol is going to be the strongest. Okay, we have these three very vital parts of the body that is going to be vital when it comes to producing these estrogens and androgens. We have adrenal glands, we have the ovaries, and then we have the testes. So with men, it's very commonly known that they're going to produce a lot more testosterone than women. And that's partly is due to the fact that the main synthesizer of testosterone, as it goes from the liver to the bloodstream, then to the testes, where it's produced into testosterone, is mainly synthesized via the testes. However, women are a lot more reliant, since the ovaries don't really make testosterone, on the adrenal glands. Now, the adrenal glands don't really synthesize a lot of testosterone, and it's a huge reason as to why women in general have a lot less testosterone than men, and it's because they rely a whole bunch more on the adrenal glands as a synthesizer for testosterone in comparison to men that have the testes to rely upon. Now, just think about it like this. They always say you can kill two birds with one stone. Well, women just have one source to rely on. They only have one gas station to give them that testosterone. And as a result, they do have testosterone, just a whole lot less. So we have the adrenal glands, we have the kidneys. The kidneys are going to have like aldosterone. They're going to release erythropoietin. Erythropoietin, also known as EPO, is going to be vital for the, what's it called? The epiphysis, the tuberculae of the bone. Basically the bone marrow, that's going to be vital for erythropoiesis, creating lymphocytes, neutrophils. These are going to be white blood cells that are going to be vital for either creating macrophages, macro big eaters that create and destroy bacteria within the lymphatic system. We also create, not only that, but we create thrombocytes. This is very vital for thrombogenesis, or it's going to be vital for basically stopping any sort of excessive blood flow. It's very vital for platelet production. And then also it's very vital for osteoblast creation, which is basically creating more bone. We have osteoclasts, which break down bone. We have osteoblasts, which make more bone. But for right now, we need to know that these kidneys, they create erythropoietin, and they also create aldosterone, which is going to be vital when it comes to, aldosterone is going to be vital for sodium as well as potassium being released within and out of the bloodstream. We then have adrenal glands. The adrenal glands are going to be vital. They're going to have the zona glomerulosa, the zona fasciculata, and the zona reticularis. And so, again, this zona glomerulosa is going to be created by aldosterone. And so, my bad, the kidneys don't actually produce aldosterone. What they do, though, is the kidneys rely on aldosterone for that synth. For basically the decision maker on how it's going to handle sodium as well as potassium. The adrenal glands, though, they're going to make the aldosterone. Then they're going to have the zona fasciculata, which is going to make cortisol. Now, cortisol is that stress hormone. And then we have the zona reticularis. The zona reticularis is what's going to make that testosterone as well as those estrogens. From then on, we're going to go into the testes. Remember the testes via there's not really much we're going to explain here for today, but the testes are what's going to be the main synthesizer of testosterone for men. Okay, and so very brief process of the process of cholesterol going into becoming estrogens is cholesterol will then become pregnenolone, progesterone, androgens. I don't know if it's pregnenolone or how you say it, but I guess when you read a textbook too much, you don't really know how to say some things properly. But what's also important to know is that estrogen is used for hormone therapy, and progesterone is the main sex hormone that occurs naturally used for menopause. And so what I want us to know is that estrogen and progesterone work together in terms of the menstrual cycle. So if we look all the way here, we have estrogen, which is the first half of the menstrual cycle. It's a thickening of the uterine line, and it's going to trigger ovulation. Okay, but we also have that second half, which is we're going to have progesterone. And so that's going to rise after ovulation, prepares the uterus for possible pregnancy, and it's going to trigger the period if the progesterone levels go down. Okay, and this progesterone is vital when in creation of also estrogen. So what I mean by that is that if we don't have progesterone, but we have a whole bunch of estrogen, there's a higher increase of what we call proliferation cells within, for example, our
what's that?
So yeah, we're actually going to break that down in a second. So we have endometrial hyperplasia, polycystic ovary syndrome. And so these are basically diseases that can occur as a result of not having enough progesterone and too much estrogen. Okay, remember that we have estrogen that's produced in the first half of the menstrual cycle. And so this is going to prepare the body for basically collecting that sperm and collecting it to the endometrium to prepare for having a baby. That progesterone, what it does is that it rises after ovulation, prepares it prepares the uterus lining for possible pregnancy. But if it goes down, that means that at the point that the egg didn't meet with the sperm, and as a result, that's when we have that shedding of the endometrium, and then we have our period, or woman has her period. We don't. But we have endometrial hyperplasia, which is excessive proliferation of cells in the endometrium. And this is directly as a result of not having enough progesterone that handles the estrogen. Remember, we need to have a balance of progesterone and estrogen. And so if we look here,